8147. Where do stress rupture cracks usually appear on turbine blades? A. Across the blade root, parallel to the fir tree. B. Along the leading edge, parallel to the edge. C. Across the leading or trailing edge at a right angle to the edge length. The correct answer is C. Turbine blades, especially those in high-temperature environments, are subjected to significant mechanical and thermal stresses during engine operation. Over time, these stresses can lead to material degradation and the formation of cracks. Stress rupture cracks are a type of crack that occurs due to prolonged exposure to high stress levels. In turbine blades, stress rupture cracks tend to develop across the leading or trailing edge at a right angle to the edge length. These cracks can initiate and propagate perpendicular to the edge, extending into the blade material. The leading and trailing edges are particularly susceptible to stress concentrations, making them common locations for crack formation. The high-temperature operating conditions, combined with cyclic loading and thermal gradients, contribute to the development of stress rupture cracks. The stresses can arise from factors such as centrifugal forces, aerodynamic forces, and thermal expansion mismatches. 8148. In which type of turbine engine combustion chamber is the case and liner removed and installed as one unit during routine maintenance? A. Can. B. Canannular. C. Annular. The correct answer is A. An outer case, or housing, and a perforated stainless steel combustion chamber or liner make up a turbojet engine's can-type combustion chamber. For routine maintenance, the case and liner are taken apart. 8149. The diffuser section of a jet engine is located between A. The burner section and the turbine section. B. Station 7 and Station 8. C. The compressor section and the burner section. The correct answer is C. The diffuser is an annular chamber fitted with a number of vanes that form a series of divergent passages between the centrifugal compressor and the burner section. As the diffuser vanes direct the flow of air into the burners, they increase the pressure of the air and decrease its velocity. 8150. When the leading edge of a first-stage turbine blade is found to have stress rupture cracks, which of the following should be suspected? A. Faulty cooling shield. B. Over-temperature condition. C. Overspeed condition. The correct answer is B. Stress rupture cracks are typically associated with prolonged exposure to high stress levels and elevated temperatures. The leading edge of a turbine blade is subjected to significant thermal and mechanical stresses during engine operation. Over time, these stresses can cause the material to weaken and develop cracks. An over-temperature condition occurs when the turbine blade is exposed to temperatures higher than its designed operating limits. This can happen due to various factors such as inadequate cooling, combustion anomalies, or operational issues. When the blade is exposed to excessive temperatures, it experiences thermal stresses that can lead to material degradation, including the formation of stress rupture cracks. 8151. Turbine blades are generally more susceptible to operating damage than compressor blades because of A. The high probability of carbon deposits. B. Exposure to high temperatures. C. Less exposure to solution during engine pressure wash. The correct answer is B. Turbine blades are generally more susceptible to operating damage than compressor blades primarily because of their exposure to high temperatures. In a turbine engine, the turbine blades are located in the hot section of the engine, where they are subjected to the highest temperatures. The hot gases produced during combustion pass over the turbine blades, and they can reach extremely high temperatures due to the combustion process. The turbine blades are designed to withstand these high temperatures and extract energy from the hot gases to drive the engine's compressor and other components. The exposure to high temperatures makes turbine blades more susceptible to various forms of operating damage. The high temperatures can lead to thermal stress, oxidation, creep, and thermal fatigue. These mechanisms can cause material degradation, cracking, warping, and other forms of damage over time. The extreme thermal environment in which turbine blades operate increases the likelihood of operating damage compared to compressor blades.